Okay, everyone. I posted this problem before problem number 72 because it is very similar. We did this in class, and I just wanted to have this ready for you so you could review it one more time if you needed help with the homework. So this is what we call a quadratic in disguise. It is a quadratic. You factor it the way you would any other quadratic, but it's in disguise because it's not the traditional x squared minus 4x minus 5, for instance. So here, our x squared is our e to the 2x. Whoops. And how do I know that? Because this is really e squared times e, oops, let me actually rewrite that. This is the same, I'm sorry, as e to the x squared. So that's our term to the second degree, if you're wondering why is this treated as a quadratic. So I'm going to factor it as if it were. And if it's easier for you to go ahead and substitute, we can do that. So let's let e to the x equal x for this problem. So in other words, wherever I see e to the x, I'm just going to use x because that's what I'm more familiar with. Okay, so that means e to the 2x, I'm going to substitute as x squared. So x squared minus 4x minus 5 equals 0. Okay, that's easy. So I can just factor that. And what are the factors of x squared? X and x. What are the factors of negative 5 that add up to negative 4? That's negative 5 and positive 1. And now I'm going to solve for x. X has two solutions. X equals positive 5 and x equals negative 1. So before we actually say that those are the answer, let's go ahead and bring e to the x back, because that's what we're solving for. So here we're saying that e to the x equals 5 and e to the x equals negative 1. So here, e to the x equals negative 1 is not in our domain. It's an extraneous solution. So we are not going to include that. So the only correct answer is e to the x equals negative 5. And if you forgot why that's not in our solution, a couple of things you can use to remember that. One thing is remember the graph. Let me see if I can get a new page here. Okay. So if you remember e to the x when we were graphing exponential functions, you'll see that e to the x is never going to equal a negative number. Our range is from 0 to positive infinity. So that's one piece of evidence why e to the x equals negative 1 is an extraneous solution. Also, there is no exponent that's going to change a positive value like e to a negative value like negative 1. So that's number 71. Hopefully that'll help you. Number 72 is very similar. Okay.